Good stuff. My name is Josh. I work on the Spring team. It's very nice to be here with you all today. It's so good to see you all. I am a Spring developer advocate, a Kotlin Google developer expert, and a Java champion. And I'm online, very online. Who uses YouTube? YouTube. Anybody? YouTube. No. Good. Okay, moving on. If you're on YouTube, like and subscribe. It's not the worst mistake you'll make, probably. I mean, I don't know, it probably is. It's a weird place. Okay, what about email? Does anybody here use email? Email. No, good, moving on. I'm on the email, and then of course there's Twitter, X. That thing is on fire, so I'm not even sure if it's going to be there tomorrow, but it's there now, so you can find me there. My friend, I come before you today to talk about Spring Boot 3.x. To me, we are in an amazing place in the Java ecosystem. We're in an amazing place in the Spring ecosystem. And today, I hope to persuade you that there has never been a better time to be a Java and Spring developer. And I say that fully aware of where we are in the world, right? Did you see this? This is the history of Spring. We released this just ahead of our big conference back in Las Vegas in August. It's the history of Spring. We celebrate this year 20 years of Spring, right? And 10 years of Spring Boot. So you can play the video game. I mean, there's a new Super Mario Wonder that looks very good, but if you can't afford that, you can always go to this. This is also very good. So there's that, right? And it's just the history of our incredible journey as an ecosystem. 20 years of helping the smallest and the largest organizations deliver value to their customers in production, thanks to the amazing combination of Spring and the Java language and the Java ecosystem. So I say that there has never been a better time, and I know of all the time that we've had. I know how long this journey has been. I was there for most of it. And it's just quite incredible to see all this. So today, my friends, we're going to kind of take a look at all that stuff. We're going to do that as usual by going to my second favorite place on the internet. Obviously, my first favorite place on the internet is production. Okay, production. YouTube is my third favorite place. Thank you. Thank you. So production, I love production. You should love production. You should go as early and often as possible. Bring the kids, bring the family. The weather is amazing. It's the happiest place on earth. It is better than Disneyland. But if you've not been to production, you can begin your journey here at start.spring.io. And so what we're going to do is we're going to build a new application using start.spring.io. We're going to build a new application using Maven because we want to use Java 21. And friends, down here we have our first question, our first decision that we must confront. What version of Java do we want to use today? Well, friends, Java 21 is almost a month old. It's very old now. It's in the distant, distant past. So there's no other question. We should use Java 21. It's the only one to use. Java 21 is the current supported GA version. Java 17 was the last long-term supported version. And in order to use Spring Framework 6 and Spring Boot 3, you must use Java 17 or later. So these other two versions here, these are just for the memes, just for the lulz, just to find out who makes terrible life decisions. You should never, ever select these in any situation whatsoever, regardless of the context, okay? Java 17 and later are technically superior. They're faster, they're more robust, they're more, they're more syntax rich, they're more capable, they're more operations friendly, they're more secure. They're more production worthy in every single way. They're also morally superior. You won't like the look of sadness and shame in your children's eyes when they find out you're using Java 8 in production. Don't do this. Be the change you want to see in the world. Do the right thing. Use at least Java 21 or later, okay? So we're going to select Java 21, but for the moment, Maven works better with it, right? Gradle will update itself pretty soon as Kotlin has support for Java 21. But for the moment, we're going to use Maven. Now, these days, Gradle is the default. And so for my New Year's resolution this year, I said, I'm going to lose some weight. I'm going to learn Gradle. And, well, anyway, learning Gradle has gone well. It has gone well, okay? I'm definitely learning Gradle. But for now, we're going to use Maven. And, of course, then we're going to use Spring Boot 3.20 RC1. And then we have a choice of what we want to name our service. I'm going to name my service service. And the reason is because I'm really good with names, amazing with names. I get that from my father. My father was also amazing with names. We had, when I was a small boy, we had a small white dog, and my father named him White Dog. Now, this dog was with us for like 10 years, and then he disappeared, and I don't know what happened to him. Maybe he got a job. Who knows, right? But then, magically, amazingly, another small white dog appeared at our front door looking for a home. And so we took him in, and my father named him Two. Now, I'm not sure if it's TWO, like the number, or TOO, like in addition to, right? Either way, amazing with names. Great with names. I get that from my father. But my mom, she tells me all the time, she says, you're very lucky that I named you. And yeah, that's probably true. Okay, so we're going to call this service. Then we have some dependencies. GraalVM-native image support, actuator support, okay? Web support, Postgres support, Spring Data JDBC support, test container support, okay? DevTools support. So we've got a few dependencies here. Let's go ahead and hit generate and open this up in our IDE, okay? So here we are. I'm going to make this nice and big. Here we are, UAO. This means unzip and open. It's a little alias that I created that points to a Python script that unzips and opens my program. It's not a big deal, for those of you wondering. Okay, so friends, normally when I start development, I want to start with the production code, right? Service, application. Here's the production code. But remember, I want to live that git, clone, run lifestyle. I want to be able to take my code, clone it, and start working on it. I don't want to have to go through a wiki page with 500 easy steps to development, right? So instead of starting here, I will start here. This is my unit test, source test Java. But here's my test main method. This is a main method in my source test Java folder. It's only good for development time. You only run it during development. And during development, you may want some extra objects that are available to you so that you can do work very quickly. So you don't have to spend a lot of time standing up infrastructure to get to developing quickly. I'm using a Java API called test containers, although we have similar support for Docker Compose. The idea is that I'm going to register a bean definition, a bean of type Postgres container. And Spring is going to start this container up whenever the application starts up, right? So it's going to launch Postgres for me. Even better, we can tell Spring, hey, you know that I want to run Postgres. You can figure out how to connect to that Postgres and automatically provide the credentials, the username, the password, the URL, just for development, right? That way, I don't have to have application-dev.properties or something like this, right? I can just have this one property, one object, and then that's it. I don't have to do that. The magic behind the scenes that makes that work is this interface, a new interface that we introduced, and it took a lot of people a long time to get this interface right. You can see it was very difficult. So here's the interface. Here it is, right there. And it took 3 of our best and brightest to work on this interface. But it really is good. It's very good, so I'm very happy with the result. Okay, so we have our test application. Where did I put it? Over here, test service application. I'm going to also use DevTools. DevTools allows me to make changes and then recompile the code and then see the changes in the class loader immediately rather than restarting the JVM. I don't want to restart the JVM. That'll take forever, right? The JVM is kind of slow to start up, but Spring is very quick, usually. Usually it's fast, unless you do something like this. Unless you run a Docker image on every single restart. Then it's going to be slow. So what we're going to do is we're going to tell Spring, don't restart this one thing. Don't restart the Postgres Docker image. Let that stay, but restart everything else in Spring. That way it's fast. Okay? So let's go ahead and run this application. I'll go to the command line here. rmrf target. I don't even have one. Okay, so we'll do maven w spring boot :test run. That's a new task in Spring Boot 3.1 and later. Okay? What did I do wrong? Mapped ports only ports. Do I have something else running? Docker ps? No? Ruh-roh. To Docker We just did a restart. Did I not have the Docker daemon running? Please. No, that's not it. Here we go. Okay, so dashboard. How much you want to bet it's a space issue? Volumes. Do I have any space? I don't know. It's not good. Not good. Something's wrong. Okay, let's see here. Mapped port can only be, okay, Postgres get JVC URL. Can I not run any Docker image? Let me try that. Docker run nginx. Internet seems fine. Docker's still there. Okay, what's wrong with it then? So, dev tools, error creating name. What happened? Like, this is canceling. Okay, found Docker environment with this. Map. Okay, we're gonna Google this, people. Never had this happen, and I like it when we can fix things together. Okay, let's see here. So, what's the issue? Restart scope, got the service connection, got the main method. What happens if we just run it in the IDE? Something's terribly wrong. Okay, wait. We'll just ditch the test container support because something is weird. This is working not 20 minutes ago, not even 20 minutes ago. So talk, docker cd talk, docker compose up. Okay. Now, let's get rid of that, unfortunately. And we'll do the horrible thing here. Spring data source URL, JDBC, Postgres, localhost, username, password, BP. Okay, take 3. Hey, okay, well, that's a bummer. No idea what just happened there, but I know that worked just recently, so that'll be fine. Okay, so now we have got the application. We're not able to really get the benefit of dev tools there, but that's okay. Actually, we will. We can actually still get the benefit of it because we're going to be able to restart the code and not have to restart that Docker image, so that's fine. So my friends, we got the test code running. Now I want to actually start making changes to our production code. And here, friends, you know the drill, right? Pretty straightforward. I'm going to create an entity, integer ID, string name, like this, and I'll create an ID like that, and I'm using records. I love records, right? Records are amazing, right? Nice, nice, nice. Very convenient, okay? And then I want to, I've got this customer repository, and it's going to manage entities of type list crud repository of type customer. So here we go, customer integer. Voila, okay? So this is my basic entity, and friends, I'm using records here, but really, this is just the beginning, okay? This is just the beginning of what's possible. I think you maybe have seen Nikolai Parlog's talk on data-oriented programming. Who saw that? Okay, very good. The basic idea is that in Java 21, there's a number of features, including records, including pattern matching, including the smart switch expression, not statement, but expression, and including yeah, that's it. Including, if you take all those things together, you get this new opportunity to deal with data in a lot more elegant way. The language, and also sealed types. Those things work together to let you deal with data in a lot more elegant fashion. I'm able to take data from across the network and turn it into a Java object very quickly, and then work with that data very elegantly. I don't have to create these giant, deep-seated types of hierarchies where the dynamic dispatch is in terms of the interface. Instead, the dispatch is now in terms of these objects that have state, and the state is the identity of the object. So for the record, we can say that the customer is identical to the ID and the name. If you take those things together, put them in a new object, you have an object that is equivalent to the one I have here. Right? And if you can make that assumption, then some very interesting things happen. The language can generate constructors, storage, toString, equals, hash code, all that kind of stuff for you. So we don't have enough time to go into all that directly, but just suffice it to say, this is a really interesting time to be a developer building services, building event-driven sort of microservices, or increasingly building smaller sort of network-centric ad hoc services dealing with data coming in over the wire. Okay, so we've got our basic repository. We've got our entity. Let's build an HTTP controller, okay? And I'm going to inject this repository like so into the constructor. And we're going to call this @controller, @response_body. And we'll create an endpoint here, get mapping customers. Collection of customers. This .repository.findAll. Okay, very good. So there's my basic thing. Let's just do Command-Shift-F9. Command-Shift-F9 is to recompile, okay? So I'm recompiling the code instead of like restarting the JVM. And what does that do? Well, down here you can see it restarts the program in 0.2 seconds, right? So this is about an order of magnitude faster to make those changes doing dev tools, okay? So now I've got the restarted code. Let's go try it out. Localhost, customers. Okay, oh, we don't have the table, so we need to create the SQL table, right? So we'll go over here, and we're going to initialize our database schema. We'll create a new file here. Create table, if not exists, customer, ID serial, primary key, name varchar, not null, 255, voila. Okay, and then we're going to create some sample data, okay? And we'll say delete from customer, and then insert into customer. And we're just going to put some people that are on the Spring team. My name is Josh. It's very nice to meet you. That's not the right one. There you go, Josh. We're going to do Oliver. We got Madura. We've got Olga. We've got Violetta. We've got Yushin. We've got Stefan. Okay, we've got Jürgen. Et voilà. Okay, so there's a nice round number. What is that? It's 1, 2, 3, 4, 8. So you can divide it by 2, and then 2 again, and it's still 2. Makes it very easy to sleep at night. I like that number. Good. And finally, we're going to tell Spring to initialize the database. We're going to say restart the application on every restart. Okay, there we go. Go back to here. Customer. Did it not? Bad. Select customer ID name. Schema. ID name. Oh, okay. I know what's going on here. PG password. Drop table. Huh. I don't know what's going on here. We will just do this the old-fashioned way. Okay. There we go. Whew. That was scary. It's been a stressful few minutes here, friends. Okay, so we have this application up and running. We have our data in the database. It's fine. Nothing particularly revolutionary about that. Maybe I want a new endpoint here, right? Like this. I'll create a new endpoint to give me all the customers by name. I'll say customers by name, string name. Return this.repository find by name. And you can see the problem here, right? Already it's very clear. We don't have this type. So I'll let the IDE do the work. Take that, ChatGPT, go here, Josh, and voila, it worked. Okay? So good. We've got the data in the database. We have our simple endpoint. Nothing particularly special about this. We're just moving more quickly, and we're writing less code to get it done. But things have not always stayed the same, obviously. Things are improving all the time. And one of the things that people might have heard about, you might have heard about it at this very show, is AI, okay? Now, we don't have a lot of I in the world. So I'm always a little bit nervous about AI, because that's going to come from a lot of people that are not I, right? But nonetheless, it's a very useful project and a very useful effort. So we have a new project here, desktop talk AI.md, and I'm just going to copy and paste this new jar to our build. We'll go here, paste, voila, okay. And I'm going to add a repository to the build. I'm going to add this experimental, okay, very important here, experimental starter for Spring AI, this new project that we just launched a few months ago. Paste that in there, Command-Shift-I, and then we'll restart this build. So let's see here. Okay, good. Restart that, And now we can use this new auto starter for OpenAI. Now, of course, friends, you need to specify a key to talk to the Spring AI implementation of your choice. Now, I've already done that off screen. I just want you to trust me that I've already done that, and I want you to forgive me for not leaking my API credential key on stage. I thought about it, but I was like, nah, I'm not going to do it. No. So I'm going to create a little controller here. At response body class, story time controller, okay? And we're going to inject final AI client singularity, okay? Now, here we go. We're going to create an endpoint here. Story, story, map, string, story, map.of. Now, the last time I did this, I'm not kidding, OpenAI was offline. So hopefully that doesn't happen to me again today. I've had enough issues. Okay, so we're going to create a prompt, and we'll come back to this again. And we're going to use this.singularity to generate a response given the prompt, var response, okay? And then we're going to pass that here, okay? So now let's write the prompt. And remember, how you ask for things matters a lot in the world as well as in your code. You can get this AI to give you a response that is programmable. You can talk to it in terms of data interchange formats like XML and JSON, right? So that's fine. Let's do it. Dear Singularity. It's very important to be polite because they will remember this when they take over, okay? Always be polite. Please write a story about the lovely people, culture, and place of Porto, Portugal. And please do it in the style of famed children's author Dr. Seuss. Cordially, Josh. Okay, very important to be polite. Good. So we're going to go ahead and run that. Command-Shift F9. There we go. And we go now to, what is it, story? And we wait. Take some water. Okay. Oh, Porto, Porto, a place so grand, with lovely people and a culture so grand. From the color of our houses to the cobblestone streets, there's so much to explore, so many treats. The lovely people of Porto, oh so kind, with warm smiles and a welcoming mind. They'll greet you with open arms and a cheer, making you sure you feel right at home here. You get the idea. It can do some really interesting stuff, okay? Very good. Now, think about what happened when I made that request. We asked for a request, we got a response back. As I was making that request, I had time to drink water, I was tying my shoe. I don't even have shoelaces, right? That's incredible. I had time to blow my nose. I mean, I took a little stretch. It was just a long, long time for us to get that response. And that's okay. It wrote a poem. I'm not mad that it took a long time, but what I am upset about is that we wasted, potentially, a lot of time on the computer. So think about what that means. We were here on line 73. And before on line 73, we were on a thread. This thread. I don't know what thread it is. Let's just call it thread 1. And then we waited for the response. And the response took, a week or 2 seconds. I don't know. It was a long time, right? And we were still on thread 1. And this is not good because right now, if you're not using Java 21, threads are very expensive. You only get to have a few of them per application. Each thread takes about 2 megabytes of RAM. They're mapped one-to-one to operating system threads. So these operating system threads are expensive. There's bookkeeping required to keep those threads. And so we want to spend as little time on those threads as possible, especially if all we're doing is asking for bytes, waiting for bytes to come back, right? Think about that. Input stream.read, we say that that's a blocking operation. You're waiting for bytes, but you're just sitting there on the thread. Nobody else in the system can use that thread. That's a huge waste, right? And this is why when you log into a lot of systems today, you'll see that their CPU is idle, and yet they're all in a wait state. They're not able to handle any more traffic, and yet there's no CPU activity because they're all blocked waiting for I/O. Most of what we do today is I/O-centric, right? So what we want is some way to get around that. Well, in 2003, or 2004, was it 2003? I don't know, 2002, they released Java 1.4. Java 1.4 had Java NIO, right? What's the Portuguese word for hemorrhoid? Hemorrido? Something like this? I don't know. I don't know what it is. It's probably something like that, right? So it created lots of hemorrhoids. That's the technical term, okay? And Java IO was not good. It was not good. It was terrible bad. So then they had Java NIO 2 in Java 7, and also still more hemorrhoids. Lots of pain. Very unhappy people. And then my friend Trustin Lee, he's a fellow Java champion, and he lives in Korea, and he built a library called Neti. Neti is a non-blocking, I/O library that powers everything right now, right? It's the underpinning of the internet at the moment, right? It's probably the second or maybe the first most used library in the Java ecosystem, like Log4j, Neti, JUnit, Spring, right? It's in that. It's basically that. That's how popular it is. Everybody uses it somewhere in your organization. You're using Kafka, you're using Neti, right? Okay, so that was a good library, but it's still very low level. It's byte buffers and input streams and all that kind of stuff. Nobody wants to think about their business logic that low level. They want to think about it at a higher level with higher order abstractions. So then we have things like Spring's reactive support. And I like reactive programming, but I understand that some people do not. It's a different paradigm. If you're coming from imperative Java, learning functional reactive Java is going to be very different for you. If you've come from something like Lisp, however, then of course learning reactive is very easy for you. So it's just a matter of how you're coming at it. So in this case, there's no option here to do reactive. So it doesn't matter. But what I want is to not waste time on this thread waiting for the AI to give me my story. And now we can. In Java 21, they introduced what I think is probably the single most important feature to ever be added to Java, which is they introduced a way to automatically move blocking things, input_stream.read, thread.sleep, these kinds of things, output_stream.write. They move those blocking things off of the thread into RAM, and when they're done executing, they move them back onto the thread. So when the bytes have arrived, they put it back on the thread so you can process it. And it all happens transparently to you. So let me show you an example that I stole from Jose Pomar. He's a Java developer advocate at Oracle. Great example, okay? So we're going to say this. So let me see, Jose Pomar, okay? There's this. Good. And it's a very simple example, okay? We're going to create a bean that when the application starts up, will launch 1,000 threads or 10,000 threads. So we're going to say int stream range 0 to 10,000. And then for each one, we're going to create a new thread, a virtual green thread using Java 21. Okay, and we're going to turn that into a list, and we're going to go through each thread, and we're going to say start, and we're going to say join, and then we're going to print out the results of our processing, which we're going to store here in a set. Okay, new concurrent skip list set. Oop. Voila. Okay, so we're going to say observed. Now, what am I going to do with that set? Well, I'm going to create a method that logs information about the current thread if I'm the very first one. So there's going to be 10,000 threads. I only care about the very first one. So let's create a method here. Private string note int index. So I'll say thread.sleep, 100 milliseconds. Okay. Let's run with try catch, and then we're going to say return thread.currentThread .toString, otherwise this. And we're going to do that only if we're on the first thread. Okay, so return empty string, which will get deduplicated because we're using a set, or return the current thread name if we're on the first thread. So we have 10,000 threads, which creates congestion. It creates a lot of contention for resource sharing, okay? But we're going to log those names here in the list. So we're going to say note, index, et voila. And we'll do that 4 times or 5 times or whatever. There you go. So let's do that. Okay. Command-Shift F9. Okay. And you can see that the program ran virtual thread 109. Virtual thread 109. But you can see that it changed threads. 1 worker 2, 1 worker 5. Right? Let me start it again. Command-Shift F9 to create some contention. And the results are different each time. virtual thread 104.3, 101.4.3, 101.4.3, 101.4.3, but here it's on a different actual thread. So it's moved it from one operating system thread to another without us knowing. You didn't see me start any new threads there. I didn't move threads out of the code. I didn't even have to do this goofy thing that the other languages have to do, like async, function, get customer, blah, right? I don't even have to do that. It just works, right? So now I'm getting non-blocking I/O scalability without having to waste my poor hands writing JavaScript, right? This is a good deal for all of us. I don't want to waste this much time writing code. I'm not getting younger, right? Java is much more concise, and now it's just as scalable. This is an amazing, amazing time to be alive. Okay, so we have non-blocking I/O, but look, I had to do this. I had to create a thread. Remember, only one person truly knows how to write safe, effective, multi-threaded Java code. And it's not you. I don't know who it is. Nobody does. But it's not you. That's the important thing, right? Don't do it. Do you know Tony Hoare? H-O-A-R-E? He's the guy that came up with the idea of the $1 billion mistake. He talked about this in the 1970s. He said that null was the $1 billion mistake. He was wrong, of course. It's PHP, and that's a $1 trillion mistake. But anyway, my point is, he also talked about how threads are considered harmful in the 70s. 40 plus years ago, he already understood that writing code in terms of threads is a terrible idea. It's just a very unsafe, dangerous way to build a system, and it has indeterminate effects, so you've got to be very careful. So most of us don't do this kind of low-level threading down by ourselves. If anything, most of us do something like this, right? Executors dot blah, blah. Okay, and I get an executor service, and I use that to launch threads. But even that's a little low level. And if you look at your typical enterprise server-side Spring app, well, there's a lot of places where you need to have executors. Well, if you're using Spring Boot 3.2, which comes out next month, then you can just say Spring Threads enabled equals true. Spring Threads virtual enabled equals true. So now we're doing non-blocking I/O in your data integration layer, your web tier, your batch, everything where we can use non-blocking threads, we will for you, okay, throughout the stack. Okay, so now we've got an application that gets much better scale. We're not wasting time writing a lot of code. This is a very concise way to write and think about objects in our code base. And we're getting much better scale. Now what? I think it's time to start thinking about how to get this thing to production. And my friends, here we have a few questions we need to consider. How do we containerize this application? Well, obviously, the first question is, how do you containerize it? Use build packs. Build packs, this is not new, but it's worth mentioning. Build packs are a great way to containerize an application. It's a cloud-native computing specification, cloud-native computing foundation specification. There's a little CLI, and you can use it to package any artifact, if it's a .jar, or .war, or .NET.exe, or Ruby on Rails, or Python, or Node.js, or I can't say it, it's not a language, but the point is, it could do that too if it were a real language. It's an amazing technology. It's an amazing technology. If you're using those CLIs, it's very, very, very fast, very effective. That said, if you're using Spring, it's even easier. There's a little command line tool you can use, right? So this is Spring Boot build -image, or if you're using Gradle, you'd say Gradle W build boot image. And it builds you a Docker image that you can then Docker tag and Docker push to your container registry of choice. Remember, friends don't let friends write Docker files. Don't do it. Be the change you want to see in the world. As soon as you're done writing the Docker file, you'll have a CVE, a vulnerability. As soon as you're done, you finish it, git commit, git push, CVE. Now you have to go back to your desk. Now what? Let build packs do it, because it powered millions of container launches and builds over the last decade from Heroku and Cloud Foundry. There's wisdom there that you're not going to get. That's okay. You don't need to get that. Let somebody else do it. Okay, that's the first thing. And the second thing, my friends, is I want to package my application so that it's as fast and scalable as possible. And here, friends, it's worth taking a moment to say that I think that Java is already very fast and very efficient. There's this wonderful blog that talks about this from 2018, before the COVID pandemic, or BC. And this blog asked the question, which programming languages use the least electricity? Very good blog, right? From 2018 BC, okay? So here we go. Looking at this table, it looks at normalized global results for energy, time, and memory. And it looks at the different languages. So we can say here that C is the most efficient language for machines, not people, definitely not people. For machines, it is the most efficient language. And then Rust, doing quite well. Zero cost abstractions, good stuff, right on. And then we have C++, tui, disgusting, moving on, disgusting. And then we got Ada, but nobody uses that. And then we have Java, okay? And Java, let's say, simple math, my friends, 2.0. 2.0, okay, round up. So we're gonna say simple math, 2.0, top five most efficient languages, okay? Very good. And by the way, remember, Java is not like any of these other ones. Java has a runtime, right? And people use it. It's a different language than these other ones. Okay, Pascal, okay, great, whatever, Chapel, nice, Lisp, OCaml, Fortran, Swift, Haskell, C#, Go, Away, Dart, F#. And by the way, what is this? What happened here? Look, TypeScript is 21.5, JavaScript is 4.45. Like 4 or 5 times worse performance, energy-wise. I thought one compiled into the other. I don't know how it's... And by the way, if you're like me, and you use TypeScript, then you should know we are both in the same boat. And our boat is sinking. Okay? I would never use JavaScript. It's a nightmare language. No, of course not. But this is a really, really bad result here. Not good at all. Ugh, moving on. The less said about these two, the better. And then we have this. We have JRuby, which is JRuby. It is the Ruby interpreter written on the JVM. And it is 46.5. Then we have Ruby, which is the Ruby interpreter written in C. And it is almost 70. So we can say it's basically a third more efficient to use JRuby than it is to use C Ruby. That's an amazing result. You get that just by running on the JVM. Remember, C Ruby came out years before JRuby. It's not like they had a head start or something. And yet it's almost a third more efficient. That's an amazing result. The JVM is an amazing piece of technology. Amazing, 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 amazing piece of technology. And then we have Python. And this really makes me sad, okay? Because I love Python. I use it all the time. I have been using it since the 1990s. Bill Clinton was president in my country when I started learning Python. So this makes me very sad. But this number is really, 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 wow. 75.8, okay? So round up. Let's call that 76, okay? You know, what's 76 divided by 2? I'm not very good at math. You know who is good at math? Python. So let's do that. It's 38. So let's say that we have a little program in Java, and when you run the program, it uses electricity. And that electricity creates carbon, and that carbon goes into the atmosphere. And then that carbon kills one tree, one little tree. The same program in Python would kill 38 trees. That's a forest. We need to have a conversation about this. This is a terrible number. That's worse than Bitcoin. I forgot what we were talking about. Oh yeah, Java's really good. Java's great, okay? All I'm trying to say is it's a very good language. So what I'm about to say is it's very good, and I think we should understand why it's very good. And I think there's 2 things that we can point to. First of all, the Java programming language garbage collector is amazing, right? It lets us write mediocre code and sort of, get away with it, right? I'm a big fan. Big fan of the Java programming language garbage collector. But I just want to say, it is not the only, or it's not even the original Java garbage collector. I think that honor belongs to this person. Her name is Jesselyn. She lives in New York City. She is from the island of Java, Indonesia, and she is the Java garbage collector. And usually the internet is terrible. Usually it's the worst. But this is a very wholesome, kind joke, right? And look at this. Look how many people appreciate that joke. Just the internet sometimes it's mostly terrible, but this is great. Sometimes the internet is great. Okay, so the Java programming language garbage collector is phenomenal. The other thing that allows Java to be so successful is the just-in-time compiler. The just-in-time compiler looks at your code and it turns it into operating system and architecture-specific native code. And it works pretty well, but it has trouble with things that violate the type safety of the type system, right? So things like reflection, like resource loading, like JNI, like JDK proxies, and like serialization. This allows types to leave and enter the JVM after the code has already started. So these kinds of things will cause frustration for the just-in-time compiler, okay? But it is a very good thing, and it works quite well. So the question then is, well, wait, couldn't I just, if it's so good, and it is, by the way, large groups like Google and Alibaba, they use this. If it's so good, then why couldn't I just turn the whole program into operating system and architecture-specific native code? That's what the just-in-time compiler is doing. Why couldn't I do that before I deploy the application? And you can, right? There's a technology called AOT, ahead of time. And this is supported by a project called GraalVM, okay? GraalVM is an open JDK distribution. It's open source. It provides all the same things as OpenJDK, plus some extras, including a native image compiler. This native image compiler works really well, except it also has trouble with these things. But there is a way to fix it. You can provide JSON files, okay? I have a problem with this, though. There's two problems. First, I don't like to say the word JSON. It just sounds stupid. I speak French. In French, you would say a JSON, which is cooler, okay? I was in Taiwan, and there they have Hokkien, and there they have Jingsong, which means happiness. Either way, you can pick a team, but this is dumb, okay? That's part one. The second thing that's a problem is that there's just a lot of a JSON required. I don't have time to write all that. I don't even have enough time to finish this talk. No. So instead of doing that, we're going to let the new Spring Boot 3 AOT engine do the work for us, okay? So we're going to go here, skip tests, native compile, and we'll let that run in the background. And it's going to take some time. And the reason it's going to take some time is because it's going to do an analysis. It's going to analyze my code and remove all the code that is not being used in the JRE, in the class path, and in my code itself. And it's going to keep only the things that are being used. Well, this is a very expensive computation to do, but it does it on every compile. So it does take a very long time. And unfortunately, it's very, very hard to work when you have to wait for this, right? I now understand this joke. I didn't want to understand this joke. This is XKCD. This is the famous compiling cartoon, right? The number one excuse for not doing your work. My code is compiling. The boss says, hey, get back to work, compiling. Oh, okay, carry on. I get this joke now. I thought this was just the C++ people. But no, here we are. Makes me very sad. I don't want to get this joke, but I do now. That's a very big shame. So it just takes a long time, and it takes so long, in fact, that you kind of get bored. Because you can't go to the bathroom or make some coffee. It doesn't take that long. But it does take long enough that you're just kind of sitting there, you know? And a lot of times when I'm doing this kind of stuff, I hear music in my head, like from game shows. I'll hear the theme song, or from TV shows, or that music that you hear in the elevator music. I hear that in my head. And I thought, gosh, wouldn't it be great if everybody could hear elevator music during their native image compilations? And so I went to Oracle. And I said, please play elevator music during the native image compilation process. I said, I already hear elevator music in my head while I do these sometimes long-running compilations. I'd just like everybody else to hear it too. Thank you in advance, and I appreciate your amazing work. And I got some great responses. This is one. This is from one of our friends over at Red Hat, a guy named Andrew Din. And he said, please can you make it this elevator music? Andrew is a distinguished engineer on the Red Hat Java team, OpenJDK project reviewer, Byteman project lead, and Graal developer. And he said, can you please make it this elevator music? I'm not going to play the music because I don't think I have the rights to it, but it's the Pierce Brosnan Golden Eye video game. So James Bond, 1990s, First one from Pierce Brosnan, they had a movie that was called GoldenEye, and that movie had a Nintendo 64 video game, and that video game had a soundtrack, and that's this. And there's a track in there that's actually properly good elevator music. I approve. Somebody else says, I would add that using beeps in general, not only for native image, really help me to reduce development time. Yeah, that's a great idea. My stupid microwave will make a ding sound when it's done. Why can't my multi-million line compiler? This makes a lot of sense. I agree with this. And then I got this response from Fabio Niephaus. He's a researcher on the GraalVM team at Oracle Labs. He's a doctor, one of my favorite doctors, along with Doctor Who, Seuss, Strange, Subramaniam, Sire, DeVolder, and Pollock. And he said, thank you for your feature request, Josh. The problem with playing music during the compilation process is that it's just fixing the symptoms. And we've been and are still working on the cause, making GraalVM native images more efficient in terms of time, memory, and CPU consumption. Okay, he continues. Anyway, I have prototyped a -- Josh Long mode. So let's see what that would look like, friends. So you're gonna run the native image compiler, native image, you can see that right there, it says native image. And then you're gonna hear music. It's a picture, but just imagine music. That's the whole point, right? So then you say -- Josh Long mode, and then you're wondering what's going on. So it says, oh, hey, you're listening to music brought to you by Josh Long. I'm Josh Long, just so we're on the same page, okay? It's very important that we're on the same page about that. And then you want something to look at, because you're still waiting, right? And so then it would print that out. Now, I'm sure this will get merged soon. I don't know when. I forgot what we were doing. Oh, right, the compilation. Let's see. Okay, so that actually did finish many, many minutes ago. That's very awkward. It was done like 5 minutes ago. Okay, so target. And target. Okay, let's run this application. All right, we have a problem because the port is in use. Okay, no big deal. We can just stop the running program. Where is this one? Yeah. Close that out. There we go. And so you can see the application started up in 0.15 seconds. So it's very, 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 very fast. But I don't care about that. What I care about is this is the process identifier. And I can use that to capture the RAM, the resident set size. So I'm going to say resident set size, and it's going to give me a number. And that number is measured in kilobytes. So you divide by 1,000. So it's 147 megabytes to run this binary, okay? Good. So now we have an application. Where's my program here? Right, and we can see program here is again. What is that? There you go. So there you go. The application takes about 146 megs of RAM. It has everything we need to be able to talk to the database. It has a data access framework, a web technology. We're using the freaking Singularity, talking to the AI of the future. It does virtual thread that scales as well as anything on the market, and it takes less code, and it's just as productive as ever. It's an amazing time to be a Spring and Java developers. My friends, who learned something new? Who learned something new? Very good. Who had fun? Who had fun? Very good. I had fun too. Thank you so much, everybody. Have a great day. Appreciate you. Obrigado. Cheers. Oh, can I take a selfie with y'all? Oh, okay. Pretend. I'm just gonna. Okay. Ready? Pretend like you're happy. Just ready. Open source. Yo. Okay. Otra vez. One more time. Open source. Thank you. I'm going to take those photos, and I'm going to show them to my daughter. And I'm going to say, see, they listen to me. Bye.